So this, I'm going to start talking, have a discussion about deployment architectures, things to think through as you're architecting your Cribl installation. I've learned this the hard way with one of the first Cribl customers way back when, and we went through some pain points, things we didn't think of, lessons that we learned. So this is more of a, void what Ed did and screwed up and had to undo and had to redo multiple times. So just mostly lessons learned, try to help people avoid the complications that we went through, the issues we went through. When we first got started with Logstream in 2018, just didn't, it's a totally new concept, even just from replacing a Splunk heavy forwarder concept. It was just still a new concept. Never envisioned that eventually we would have Logstream installed in 20 plus countries and 5 continents, with that we would have a large number of people working in Logstream. So we just never envisioned that they'd have a number of roles, a number of people. Just the thing, it just didn't occur to us, or it didn't occur to me, how much this was going to expand over time. And so the idea, that kind of the principle of it is the principles is act as if you're going to grow, you're going to get bigger, things are going to change. And to put those initial foundations in place, because otherwise you're going to end up having to undo things, redo things, and no one has time to redo to redo things constantly. Even though that's the nature of life, but we're going to try to avoid that. Just have a quick overview. As everyone knows, your observability pipeline, Logstream sits in between your sources and destinations, and it's great. You're sitting there. But there's things you want to think about, especially in terms of scale, scope, complexity, that you want to start thinking about early in your deployment instead of later. And so you can clearly see you have the ability to route data, reformat data. It's amazing all the different things you can do. Igor had a blog post about how you can actually use Logstream to detect certain patterns to combat the log for hell issues that are going on now with everybody. Just the flexibility is endless. You're only limited by your imagination. So in interdeployment principles, I always like, this is from being an enterprise architect for way too long, always plan your initial architectures as if your data volumes are going to grow. Nothing's going to slow down. It's not going to get smaller. So think through how you're going to put the foundation in place to be able to grow with the least friction. Your complexity is going to grow. So the number of Logstream instances, your data, what people want to do with it, where your data is located, how data governance, security is going to get involved. It's going to get more complex over time. Especially one thing to keep in mind with Logstream, the more you transform the data, the more you're going to hit the CPU. So you have to make sure you're going to have access to adequate CPU in order to accomplish your goals. Also, teams are going to find out about Logstream. They're going to think, wow, that's really cool. I want to do this too. So how do you start setting up your role-based access controls or your architectural methodology in order to accommodate more teams using Logstream to get work done? Very common to start bringing in dev teams to build it, pipelines and various things with their data as part of the development process, which can be great because it scales out the number of people who are working in Logstream, brings more smart people to the table. You want to think about it because it's just a totally different paradigm from 2 people working in Logstream to 50. And finally, something's going to fail. Plan for failure. Know what will happen when your infrastructure starts to fail. Anyone have any questions so far? So let's start with data volumes. Always use load balancers whenever possible, even if it's just one server in your pool. I run into this quite a bit when I was talking to prospects and customers where they say that we only have a small amount of data in this data center. We're just going to point our endpoints, our devices at this one server. And eventually it's an old story. You're going to grow past that one server. And so then you got to put a load balancer in place. Then you have to redo all of your endpoints to point at the load balancer instead of the servers. Avoid the trouble. Even not just beg people, please avoid the trouble, avoid the delay of rework. Use that load balancer to begin with. And then also that's going to help you plan for HA. It's going to help you plan for failure. It's just so important. And that goes back to deploy more than one server in every load balancer pool, if at all possible. That gives you the ability to fail over. It gives you the ability to scale. Also, ignore capacity management. Don't let them talk to you. Don't let them talk you down out of what you need and saying you're only using this much CPU on average. The average is not what you plan for. You plan for your spikes. One thing I try to work with the business to do is what's the highest acceptable level of failure? If we get to X amount of data, are you going to be okay from a business standpoint? If we don't have enough hardware, and you're going to fail. And that puts the question to the business of we have to start thinking about these things. We have to plan for them. And it's a constant give and take. Had it happen too many times. We work with a business unit and they say that, oh, that'll never happen. Our VMware infrastructure is great. Then we have a major firewall failure. And then all of a sudden it's 500 megs per second, a gig per second, pointed at a couple of VMs, and the whole thing just doesn't work anymore. And so it's a constant negotiation progress. You got to keep working with people, but your capacity management is for your spikes, not your average utilization. The small diagram, the idea is, and this is also something that it's initially when we first started out at TU, we had one worker group. We eventually learned that we needed to have at minimum 2 worker groups, one for agent-based data collection, the other for agentless data collection. When I say agent-based, so that's going to be your log shippers, your FluentDs, your Beats, your Splunk Universal Forwarders, and then your agentless is going to be your HTTPS, your Splunk HEC, your syslog delivery. The idea that you're going to have very different patterns of data, very different workload utilization. Also, the connection overhead can get really extreme certain. So I'm going to split this up. So this helps us also from a scaling standpoint, and also helps us from an HA standpoint to break this up. And for example, if our agentless data collection is running much hotter, we can add CPU over there, and we can just have more control over your environment. Is the idea of the agent versus agentless data collection making sense to everyone?
Yeah, in general, you have Splunk UFs listed on both columns. How is a Splunk Universal Forwarder not an agent? Or is that just a...
That's my mistake.
Oh, okay.
Yeah. But the idea is that from an agentless standpoint is it's just in terms of breaking up connection overhead. Yeah, you're right. But that's the idea. Is just I recommend breaking it up and having this as your minimum installation where you're deploying two VMs in each group. You're putting a load balancer in front. In terms of your agent-based data collection with your load balancer, you don't always need that. You definitely don't need that with the Splunk Universal Forwarder, but with some you do. So it just depends on your needs there. But you definitely want to have a load balancer on your agentless side. Also, typically use the agentless for your API-based data collection. So if you're going out to AWS, if you're going out to Azure Event Hub, put that over there. And also just be aware you're going to have more hotspots on your agentless data collection due to the inability of load balancers to very cleanly load balance, especially high volume syslog traffic. You're going to have much more even utilization on the agent-based side typically. So just be aware, typically what we would do is we would have more CPU on the agentless side in order to handle the hotspots. Your complexity is going to grow. Sometimes you see particular business units start to adopt Logstream. Plan for it to start to grow across your entire enterprise. So potentially every business unit. One particular pattern I see quite a bit is that will have siloed logging teams or siloed observability teams, and then organizations will start to get smart and start to plan an enterprise observability or a logging team in order to cover the needs of the entire enterprise. So you'll start to see consolidation and then spread. And so if you can think about how your leader can be placed to eventually manage the entire organization. Ideally, you want to try to keep things as simple as possible and not have leaders everywhere, not have just and manage the messiness and manage your complexity. It's not always easy to do, but it's something you want to think about as you're doing your architectures, if at all possible. Also consider the different data types of your enterprise. Think about if you have if your business unit is in healthcare and is bringing in just to manage healthcare data, but then it starts to spread to other places. You're not going to want to potentially route data through the healthcare worker group because of the issues around PHI. So this comes from as you're managing complexity, create new worker groups to manage different types of data. It really helps from an auditing standpoint. And then again, it depends upon your business, but use the worker groups as a way to concentrate your particular data and then manage it. So instead of having healthcare flowing all over the PHI flowing all over the place, it comes through the PHI worker group, or it comes to the PII worker group in order to know where that data is. And it helps from a data governance, helps from security, it helps over controls. It also helps from your RBAC, as we're going to talk about a little bit later. And also, you will find new and wonderful ways to enrich data. At first, it'll start out, okay, we're going to use LogStream to drop data. Then you're going to start to say, okay, we can enrich data. We can add data back. We can do other things with data. We can split it. We can completely change the format. We can deserialize XML over to JSON. And those are the things you want to plan for, because your scale really gets impacted. As I mentioned before, that's where you start to see CPU utilization. And I'll talk in the final diagram, I'll use some of the lessons we learned there in order to talk about how to handle really complex data transformation. And this is where, from a large deployment, I was kind of thinking is where things get more complicated. You want to be able to use your worker groups as lanes of planning your data. So this is a good example of what we did at TU, where we had worker groups in each data center. And they all funneled data back to a primary processing worker group. We had mostly VMs in the data centers because they were routing and dropping data. But then as we transformed data, especially going back to security, that's where we went back to what we called our core processing worker group. The core processing worker group is made up of very large physical servers. So instead of 8 to 16 core VM cores, we're talking about 70 physical cores in the server. So we had much more resources to transform and manage data, and also that overhead in terms of spikes. When you have the entire enterprise of syslog, for example, coming back, you want to be able to go to you need to hit a gig per second. You need to be able to hit a gig per second. We also had a dedicated worker group for replay. If your incident response group or what gets really involved and really interested in replay, when you're pulling a large amount of data, it's one more thing that can drag down other workers. And so the idea is we just use the different worker groups as a way to segregate, manage data, and also segregate workloads. And that's the beauty of using the LogStream leader, is it makes it extremely simple to be able to monitor and understand what's happening in all of your worker groups. Has anyone else, and I know Eugene did at your last job, use what I think of it like a front end or routing worker groups and then go back to your core worker group. Has anyone else tried that before? Eugene, can you talk about some of your experiences doing that?
Let me unmute hardware and software. There we go. Yeah, so we ran into the problem that previous employers was that the load balancer was not able to reliably keep up with the traffic that was coming through and spread it between the syslog servers. And we were standing up the Cribl LogStream servers to replace those, and running into the same issue where the traffic wasn't being spread. It was either sticky or the file was getting overloaded. And what I ended up doing there is standing up, basically we call them buffer worker group. So big enough VMs that can take in the traffic, even if everything is going to one of them. And then all it was doing for that worker group at each site is taking in the traffic and sending it over to the worker groups that did real work, quote unquote. So, and then had some persistent queuing. So if something downstream was held up, it would just queue up and then send it when available, but we wouldn't be losing UDP because of, these machines weren't doing anything else other than just making sure they got the traffic and forwarded it on.
Yeah, and that's that hotspot I was talking about. you're especially with the way UDP data, high speed UDP data, you're going to see a load balancer is not going to have the ability to cleanly break on data. So you're going to see one server is going to have more data than the other servers, and so then that's a great way to kind of illustrate that point of you need to be able to handle a large amount of the data. You can't say, oh, here's my total split of data, we're going to divide it by 5 and assume an even split, because it's just that's unfortunately with high speed data, especially with TCP syslog, that you're going to have significant hotspots. So you just want to be careful. I would avoid TCP syslog if you can, unless you have a very skilled load balancer team who can manage that, because you really start to see issues with scaling. Logstream's going to have a tough time scaling up. You want to be able to scale out instead, and so it's just things you're going to be aware of.
Can you clarify what do you mean by scaling up versus scaling out?
Well, so for example, so say you have a 16 core VM and say you have 3 16 core VMs and you're using TCP syslog and your load balancer is locking up 90+% of the data on one VM. Going to 32 cores isn't going to necessarily increase your ability to ingest data, because the worker is essentially stuck on the socket, and only one worker is handling all of the data. There's no real internal load balancer. You need Logstream you need the load balancer to break up the data in order to spread the data across workers. But if it can't break up the data, only one worker is taking all that data, and it's one worker per one CPU. So you can maybe replace a server and get a bigger CPU and a bigger CPU core, but adding more cores itself isn't necessarily going to help you. Does that make sense in terms of the going up versus going out?
Yes, it does. Yes.
Yeah.
And so, can you also comment about what the TCP plus TLS compressed means in that in your drawing?
Oh, so Logstream is taking in the data as UDP. So UDP is going to be not compressed, not encrypted, not secure. Once you get that data to Logstream then talks to itself as compressed and TCP. So you're going to get robustness, you're going to get the ability to queue, you're going to have encryption. So all the big advantages over just sending raw syslog.
Okay, cool. Thank you.
And this is something I can do. We had a video not too long ago where we discussed scaling syslog, and ideally you want to put your syslog collectors as close to your syslog sources as possible. UDP data, as I've said before, is the devil, and you don't want to trust it. The more firewall hops, the more network hops, the more risk you're going to lose that data. And so if it's very important for you to be able to capture your syslog data, you got to put your collectors as close as possible to it. Does that resonate?
Yes, it sure does. So, because I know very intimately the problems with UDP syslog, because during my system startups, there's a lot of messages that happens, and when there are crazy trading days, the applications start getting really chatty, and I get about a 4 to 5% drop. So I've moved away from syslog. Literally yesterday was the last day when I finished it, and I moved to Splunk forwarders. So now I'm getting real robustness with elastic capability of the with Logstream handling any ebbs and flows of data very well now. So I'm very happy.
Yeah, we did the same thing. We because of the nature of just syslog on every server in the environment, we started turning syslog forwarding off on the servers and use the Splunk Universal Forwarder. And for those that are not Splunk, you can use Beats or something like that as well for this, where you're picking up the data off the server and forwarding, because you're going to get much more robustness and you're going to minimize your data loss in comparison to relying upon syslog.
Thank you so much.
Oh, glad. But so as far as is this resonating with everyone? The idea of being able to large versus small. So this is, for example, we had data centers in the heart of Africa. We had Logstream installed in Kenya, for example, running on very, very small VMs because resources were so constrained. We were able to get that forwarding capability off of 2 core VMs, getting it back to our main processing worker groups. So we're talking worker groups from 2 cores all the way up to 700. Also plan for interest to Logstream to grow as people find out about it. So you want to start thinking about early on about your role-based access control. of creating your LDAP groups, probably your AD groups, to be able to segment your access to what you need. Start considering the GitOps workflows that were just released as another way to manage access and control. You don't want everybody and your brother to have root access and being able to have conflicts. You can especially run into conflict, as you're committing to Git on, potentially on the same pipeline. Those are kind of things you just want to avoid. A couple of things to think about. Have review sessions. So the idea is that you have one group writing your code, another group reviewing it, another group that's actually going to commit and deploy. One thing we had a lot of success with is we'd have Tuesdays and Thursdays of review time during our team stand up, and then the overnight team would actually do the deploys. So it was a great way to just, not have to get people out of bed and to break up the workflows, but you don't ever want to hit, oh yeah, we just need to make a change. We're just going to stick to the discipline of reviewing your code changes, discussing it with everyone, make sure everyone understands it. As your code bases grow, this gets real complicated. The dependency mapping can get out of control. So we really want to keep thinking through it, keep refactoring your code, trying to keep things as simple as possible. Also plan your worker group deployments accordingly. This is about and that's bringing back the ideas about using a worker group per types of data, per types of sensitive data. And so either per data center, per whether it's PII, PHI, and it's because you can apply your RBAC to the worker group, so you can then also work with your data governance team to show that you have control and knowledge over your data flows. This is kind of a medium deployment. This is the idea. This is why I mentioned over here is with PII data processing, where all the data comes in through here, and then that gives you the ability to control it, to have control over it. So this is something that if I'm sure many of y'all work in highly regulated spaces, where we had what we consider general operational data. So your generic messages from systems, your generic messages from applications, and those would flow through broad-based worker groups, so they'll mark agent-based and agentless. And then we had our other types of data versus PII. So we were able to maintain different types of controls over this data, just trying to have a more visual representation. We had worker groups for PHI and all of the above in order to try to manage this access. Is anyone working healthcare or anything with anybody working at a sensitive data organization, or with data if you're working in international or international organizations where you're having to deal with different countries have different rules or how you have to handle their data? So, but this is one way to do that. And so just think about that. Think about the types of data you have and assume you're going to grow. And finally, plan for failure. Do you know when your deployments will fail? Do you know at what level you're going to start to see drops? Do you know at where you're going to start to see losses? It really helps to be able to lay this out for your leaders in terms of for your capacity management, for your AHA, for your business impacting failures, to help them understand at this level, we're going to have problems. Review this with your security leaders. Review this with for contingency planning. You'll be really surprised what your business partners will be willing to support if you can tell them where things are going to start to go wrong. I've been really surprised with business leaders because you can give them that certainty. Well, not necessarily certainty, but at least give them an idea of the investments you need to make long term. More than likely, they're going to give you more investments. And also from certain regulated industries, when you go into auditing, you would go into audit, so you can have this kind of information. You can then have a plan of here's how we're going to get to this, this, and this. I mean, for example, we had a project about going into 5 nines. And so over a period of years, how are we going to get to here, 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 and not have failure, not have data loss? You just want to be very careful because it's very easy for leaders to say, we can't lose data. And it's like, that's fine. Then here's what we have to do in order to not lose data. It's because there's as everyone knows, there's no free lunch. In order to have high availability to not lose data, you have to invest. It's also important to know the business impact of failure. For example, losing PHI data can impact you with the healthcare regulators, potentially get you cut off from things like Medicare. And so you want to be able to articulate that to your leaders. Don't assume that your leaders are going to quite understand, okay, we lose all this data and it's gone. What are we going to do about it? And so it helps you articulate that. Have you been planning for high availability? Do you have single points of failure? You want to document those and bring them up to your leaders and say, do you care or do you not? And if we do care, here's the plan to deal with it. And finally, do you have a failure plan? If your primary data center goes down, what are you going to do? Do you have the ability to use something like a DNS load balancer? Do you have the ability to have global failover? Do your endpoints have the ability to queue? The big thing about Logstream is something that a big reason why we put Logstream in all of our data centers worldwide was the ability to queue, the ability to survive a systemic failure. That was it was a big benefit, and I was glad that's something that we thought about early on because we had exactly that. And once we were able to bring up the data centers, data came back in, data started flowing. So I mean, it was really nice. So that's all I got. So does anyone want to have any questions, anything you want to review, any diagrams, anything you want to go back on, any kind of feedback?
Hey, Ed. I got a question about the worker groups, right? Why do you separate the agent and the agentless worker groups there? What's the theory behind that?
Well, it was the connection overhead, especially on the agentless side. This goes back to learn from how I screwed up. That we pointed everything at a discrete set of servers, and so I didn't quite understand how we would get multiple servers would get overwhelmed by would stick with syslog traffic would stick on them, and then you would see the utilization go through the roof, and they would have problems with queuing, problems with dropping data, problems like, for example, with universal forwarders, we'd see a huge rate of don't talk to me, come back later. And so we would see, out of an 8-node cluster, for example, 4 nodes would be stuck with syslog. The other 4 nodes would have every single Splunk universal forwarder pointing at them because the other 4 nodes were too busy. And so we weren't able to scale. And so by splitting it up, we were able to have real smooth distributions with the universal forwarder data, and then we were also able to put more CPU on the agentless side in order to handle the hotspots. Does that make sense? Does that resonate?
Yeah, I get it. Okay, cool. Thanks.
Yeah, and just to go back to that, the amount that connection overhead was just enormous, and this is also why we ended up splitting up our core processing away, because initially we started up, okay, we're going to be transforming data in our core side too, and then those things we started getting impacted. We started seeing an enormous latency and transformations of data because they were so busy just handling the connection overhead. So by splitting up the connection overhead from data transformation, we were able to get more scale and more predictability as well. Let's see if I can go.
So I'm guessing if you have a load balancer or an F5 in front of Cribl, right, and sticky sessions disabled, that would also be a method that you could combat something like how you were just talking about.
Well, we had to use layer 4 fast performance. I'm not saying this right. We had to use a very particular F5 profile in order to get high speed load balancing. And even then, we would still see inordinate stickiness in the data. And the way like the F5's text explained it to us was that the overall traffic on the F5 was so busy that the CPU didn't have the ability to break. Now we could put eye control rules to force it to break, but then we'd risk data loss if we did that. And so those are some of the things we just had to learn to live with.
Okay, yeah, it's definitely interesting, something to think about.
A lot of it was scale. Golly, it was billions of events every day of just ASA syslog. We started about 2 years ago. We reached 1 trillion events a day of syslog. I couldn't believe there was that much data coming in through that. But then you see the counts, and there it is. There's just no denying it. And And so just the scale, if you're seeing smaller scale, I think smaller scale is more manageable. But again, I think it's important. I think it's really important to put your position to grow with as little friction as possible.
Yeah.
Does that make sense? And so just, plan, definitely plan for growth. Plan, and talk to your F5 admins. One of the things we started to run into as well is like when we first started this project with Splunk, that when we first started this whole project, we ran into just one issue after another. I mean, it was unreal, and we actually had to get bigger F5s in order to handle it.
Thanks, Ed.
Does anybody else have any questions?
Yeah. Do you have any comments or thoughts on dynamically scaling groups tied to pulling data from perhaps S3 as part of an ad hoc collection run?
Yeah, and that's something that we were looking at before I left in terms of replay, of being able to do the stat of spinning up containers to do that, because we had just a few dedicated VMs to do that. But I think from replay, that's an ideal way to do it. One of the things we were trying to work at is, so like with like the Splunk Universal Forwarders, we just couldn't figure out a good way to add more workers to the list for the list of for the list of indexers in the Splunk Universal Forwarder. But from an agentless perspective, and in AWS especially, we could scale the load balancer pool easily. And so that's another thing we're looking to do is move the syslog containers into AWS and the syslog worker groups into AWS, and be able to use EKS in order to pull up more containers, because that's a great way to do it if you have access to those kind of resources. I think it just depends on at that time, especially if the company just wasn't prepared to do something like that. But if you're very comfortable as a company with cloud, I mean, that's an ideal way to get more scale and auto scale into it. Thanks for bringing that up. I mean, it's a great idea. But the other thing is just you in order to auto scale, you need to have some way to measure your throughput and have a way to trigger it. Because if you're going to have to do that manually in terms of auto scaling, you just have to put some thought into the rules around it.
Yeah, that makes sense.
Anybody else have any questions? Anything I can do? If y'all want to, if you engage one-on-one in the community, please let me know. Glad to sit down with anybody and go over these concepts. I definitely want to hear of any struggles y'all are having, and any kind of issues, questions. So we're here to help.
Yeah, thanks, Ed. That was great. And if anybody has questions around other topics, we've got a lot of brain power on the phone that I'm sure we could try to help out as well. So if there's other questions, comments, other topics, maybe we can have a discussion. We still have a little bit of time.
So this is Gav. So basically, as I said, I'm planning to onboard Kubernetes and Kafka-based microservices stack here at work. This is the first time around. So do people have any thoughts, suggestions, ideas on how they've integrated Logstream plus Splunk or Elastic or whatever to observe their clusters? Caveats, any things, or is it a different discussion altogether?
Can you clarify, are you talking about observing the performance of your clusters or the actual application logs inside of your clusters?
No. I guess both of them. I want to monitor the performance of my cluster and the state of the microservices inside the cluster.
So I was at Workday before I joined Cribl, and we were using FluentD to route data from our applications. But there was a team that was also looking at AppScope because they had jury-rigged a FluentD hookup inside their application, and they wanted to look at an alternative app collection method. But FluentD to Cribl is very straightforward. If you already have a FluentD routing, which we had set up already, an output, so we just basically forked at FluentD to send to both CloudWatch logs and to Cribl. You don't have to do that. I mean, that it was a bit of a duplicate, but because of bureaucracy, we had to do a fork there. But FluentD is very straightforward to send as a push right into Cribl.
Okay, cool. I'll look into that.
Anyone else? Questions, comments? Michael Donnelly in the chat made a good comment here. For any customers, prospects, anyone using Cribl out there, if you want to get deeper into architecture, kind of based on some of the things that Ed went through today, reach out to us. We'll be happy to get you set up with somebody that can, kind of on a one-on-one basis, drill in deeper. So thanks for that comment. And if there's nothing else, we are off for the holidays. Back on the 12th of January with Ahmed Kira. He's going to be covering AWS S3, Cribl best practices and considerations for anybody that is interested there. And then Alex Kane, who was just speaking, will be on the 26th talking about Azure data onboarding. So we'll have a couple more topics coming in the new year. Appreciate everybody's time, and thanks for joining today. Ed, great job. I don't know if you have any closing remarks, but appreciate everybody's time.
Thank you very much. I appreciate it.
Thanks, Ed. Great job.
Everybody have a great rest of your day. Thank you.
All right, thank you.